Hello and welcome back. In this video, we discuss about the concept relative velocity. Relative velocity of an object is the velocity measured relative to another moving object. For example, imagine that a car is moving at a speed of 70 miles per hour in a highway. It simply means that it is the velocity measured by a stationary observer. If the observer is traveling with the same velocity parallel to this car, the observer feels no motion with respect to the second car, or zero velocity relative to the second car. If he moves in opposite direction, he measures the velocity of the second car faster than its actual velocity. In this video, we discuss how velocity of an object can be calculated relative to another moving object. To better understand the concept relative velocity, consider motion of a car 1, from point A to B, which is measured by an observer in a fixed coordinate system with origin O. Velocity of car 1 as measured by the observer in the fixed reference O is v1, which is equal to displacement divided by time of travel. Let the time of travel be 0.1 hour. We can calculate the average velocity of car as measured by the stationary observer as 20 miles per hour for a displacement of 2 miles. Let us represent this velocity v1 of car 1 measured by the stationary observer in a coordinate system as shown. Now consider motion of a second car 2, where another observer is traveling in a parallel road for the same period of time as car 1. The observer in car 2 has a coordinate system O' fixed to the car 2, and it is moving with the car. The velocity of car 2, or the moving reference O' with respect to the stationary observer O, is the displacement of O' as measured by the stationary observer divided by the time of travel. We can see that this is equal to 70 miles per hour. Now we see that the car 1 is moving with 20 miles per hour and the car 2 is moving with 70 miles per hour. Let us represent this velocity v2 of car 2 measured by the stationary observer along with velocity v1 of car 1. This is also the velocity of coordinate system O' with respect to coordinate O. Finally, consider the same motion of car 1 from A to B observed by the observer sitting in a moving car 2, where a coordinate system O' is fixed inside the car and it is moving with the observer. Velocity of car 1 as measured by the observer in the moving reference O' or car 2 is equal to the displacement as measured by this observer divided by time of travel. The displacement measured by moving observer is O'(B) minus O'(A), which is equal to minus 5 miles. And the velocity of R1 relative to car 2 is represented as V12 is equal to minus 5 by 0.1, which is equal to minus 50 miles per hour. Let us represent this velocity of car 1 measured by the observer in moving car 2, or the relative velocity of v1 with respect to 2 as v12, along with other velocity measurements. Now we can see that v12, or the relative velocity of car 1 with respect to car 2, is the same as vector difference between velocities of car 1 and car 2. That is, v1 minus v2 equals minus 50 miles per hour. In general, we can say that if VA is velocity of an object A and VB is velocity of an object B, then the relative velocity of A with respect to B is VAB, which is equal to VA minus VB. In a similar fashion, we can say that the relative velocity of B with respect to A is VBA equals VB minus VA. Thank you for listening, and come back to listen to our tied-up video demonstrations.